Hello, my name is Mr. Asprey, and this is my Edexcel IGCSE exam series 2, where I look at all 60 topics on the Edexcel IGCSE. I split the exam questions per topic, and this is number 38, set theory. It's the second time I've done this, so check out series 1 if you want more questions with video solutions. Okay, we are looking at the union, which means that we're looking at all the elements which are in B, or they can be in I. So B is in B, so that's in. R is in B, so that's in. So is A, so is Z, so is I, so is L. And then also the elements from I are also in, which includes I, but we've already got I, so we're not going to write it again. R, again, we've already got R, we're not going to write it again. E, L, we've got L already, so we don't bother writing it again. A, we've got that already as well. N and D. So those are all the parts of the union. Now the next one is the intersection. So that means that it has to be in both of the two sets. So we have, it has to be in the Brazil set, and also it has to be in the not in the I set. So it's all the ones that are in B but are not in I. So that includes B. R is in I, so we can't include that. So is A. Z is in B but not in I. And that's it. So it's just B and Z, because all the other ones are in I and we're not allowed to include those ones. Okay, this says that Kenya is all the letters of Kenya, set K. Cody writes down the statement that B, N, K is empty. Cody's statement is wrong. Explain why. Well, it would be wrong if there was an element which is in B and K, and that element is A. We've got an A here and we've got an A here. So for that reason, the set of B and K is not empty, and we can simply just write B, N, K is equal to A. And therefore it's not empty. Therefore it is not empty, like Cody suggests it is. Unlucky Cody. Next question, now we're looking at the intersection between A and B. So those are all the ones which are in A and are also in B, but obviously must be in the universal set as well. So we have multiples of 3 that are odd. So it's 9, it's 15. And that's it. Now A union B are all of the elements that are in A or are in B, or both. So let's go through them one at a time. 9 is a multiple of 3, so that's in. 10 is neither. 11 is odd, so that's in. 12 is a multiple of 3, so that's in. 13 is odd, so that's in. 14 is not anything. 15 is multiple of 3, so that's in, and it's odd. 16, no. 17 is odd. 18 is a multiple of 3. 19 is odd. And 20 is neither, so it's just those right there. Is it true that 24 exists in A? Tick one of the boxes, explain your answer. The answer is no. It is a multiple of 3, so you might think it is in A, but it's not in the universal set. And A is part of the universal set, so therefore 24 is not in A. We can say that 24 is not in the universal set, therefore is not in A. Perfect. But there's more. Set C has 4 members such that C intersection with not B is equal to 10 and 18. List the members of one possible set C. Okay, so let's just remind ourselves that B are the odd numbers in the universal set. So if I just come down here, it means that B is equal to 9, 11, 13, 15, 17 and 19, which means that not B is 10, 12, 14, 16, 18 and 20. They're all of the ones which are not in B. Okay, and C, we know has 4 members, because it says it here, and we know that 2 of them must be 18 and 10. So we need to find the other 2. Now, all we know is that if, for example, if I put 12 here, then in fact this would be wrong, because if 12 was in C, then the intersection between C and not B would be 10, 18 and 12 as well. So we can't have any more numbers which are not in B. So essentially it means I can choose any 2 of these numbers here. So I could just choose 9 and 11 and that would be correct. Just any 2 from the set B to fill up the set C so that it has 4 elements. So I can say 9, 10, 11, 18. That does the job. Okay, next question. Another one very similar. The intersection are all of the numbers which are odd and multiples of 3 that are in the universal set. So that's 21 and 27. The union are all the numbers that are in A or in B. So let's go through the universal set, and as long as they're in one of A or B, then it's fine, we can add it in. So 20 is neither, 21 is both, 22 is neither, 23 is odd, 24 is a multiple of 3, 25 is odd, 26 is neither, 27 is both, 28 is neither, 29 is odd. So those are all of the, that's the whole union. And that's that question done. Okay, next question, we've got a Venn diagram that we need to fill. So A and B, that's the intersection, which on a Venn diagram like this will be the centre where A and B intersect. So that's 5, 10 and 15. And then we've got actually B naught and A naught, so all of the things which are not in B and not in A. So let's work backwards. Actually, we've already placed 15. Let's place 14 next, because I can see the 14 is not in B and it's not in A. So if it's not in B or A, then it must be outside. Okay. So all of the ones which are in both not A and not B are outside by that same logic. So 8 is another one which is in both, so that has to go outside. And 7 as well. So I think that places all of those. Yes. So now all the ones that are not in B and are not on the outside must go in this section here. So that's 9, 11, 12 and 13. And then all of the ones which are not in A but also not on the outside are 6 and 4, 4 and 6. And just double check that we have all of the ones that are in the universal set here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, so we're all good. Okay, so let's do the intersection of A and B. So that's where the A and B collide, which is 24 and 30. They're the only ones which are in both A and B. And not A are all the ones in the universal set and not in A. So 21, 22 is in A, 23 isn't, 24 is, 25 isn't, 26 6 is, 27 isn't, and 28 is, 29 isn't, and 30 is. Okay. So C is 23, 25, and 29. Using set notation, find an expression for C in terms of A and B. Okay, so it looks to me like these are all the numbers which are not in any of A or B. So 23, 25, and 29 aren't in A or B. So therefore, they are, so C is equal to not A and not B. So the numbers which are in not A and are also not in B. And it's important that it is an and, because just to add, if it was this one here, then that would include all the numbers which are not in A. So that would include all of these numbers. These would all have to go in, and so would all the numbers which are not in B as well. So that would be more than just what this C is given. So it has to be an and there. It has to be the numbers which are not in A and are also not in B. Okay, next question, and we've got this n notation, which means the number of elements as opposed to a list of elements. It just tells you how many elements there are. And we've also got the union, and we've got A and B. So I'm going to use this formula that the union is the same as, if I add A and B together, well, let's see what happens when I add A and B together. So that is A is all of this, a bit messy, but you get the idea. And then if I add on B, which is all of this, then we actually get a repeat in the centre. So this isn't actually equal to the union because we get this green part which has been added twice. So any element which is in the middle gets counted for twice because you add it from A and you add it from B as well. Which means you need to take away one of the middle parts, like so, and that will give you the union, because if you take away this green part here, or if you take away one of them, then you end up with having the whole Venn diagram filled perfectly once and once only. Okay, so with that being said, we have 68 is equal to 62 plus 30 minus this middle part. So we can write this, we can do that, and then we can rearrange that, so that is going to give me 24, which means 24 goes in the middle. So if 24 is in the middle and 62 is the whole of A, that means it needs another 38 in order to make 62 when you add it to 24. And over here, this part of B must be 6, because when you add it to 24 it makes 30. So that altogether makes 68, which means the outside must be 12, because 68 plus 12 gives you the 80, which is the overall. Okay, so a very useful formula to know this. And once again, it comes because when you add A and B, you actually get an overlap in the middle. So take away one of the overlaps and you end up with the union perfectly. Okay, it says use a Venn diagram, find the probability that the element is in the an element is in the intersection. Well, the intersection is 24 and out of 80. You can simplify if you wanted to, 3 over 10, but you don't have to. It doesn't say you needed to. A union not B. Okay, so lots of people get a bit confused about this. They think that A union not B is this part. That's A intersection not B. A union not B includes a lot more, because you're the union, which means you're allowed to be in either A, which all of these people are in A, so they are included, or you could be in not B, which is including this as well. So the answer would be 38 plus 24 plus 12 all over 80, which is the same as 74 over 80, which you could simplify to 37 over 40 if you wanted to. Okay, we've got these numbers inside this Venn diagram represent the number of elements, not the elements themselves. And it's asking for the number which is in union of A and B. So the union is everything that's in A, or I can shade everything which is in B. So I need to add these numbers up. So 12 plus 10 is 22, plus 6 is 28, plus 5 is 33, plus 3 is 36, plus 9 is 45. Okay, next we've got not A and not B. So in order for me to do this, if I shade in not A, which is all of this, and I shade in not B, it's going to take me a while, then the intersection is where these two things overlap. So basically that means that I'm looking at anything which is green, because that's where the two sets overlap. So the ones that are green are 4 and 8. And that's it. They're the only ones which are in not A and are in not B. Maybe that was a bit of an elaborate way of doing that question, but maybe shading is helpful for some people. Okay. Well, again, we can do some shading here, which is going to help. So, A intersection B. Now, A intersection B is relatively straightforward. It's just the middle of A and B. So I can shade that set in. That's A intersection B. And then union with C. So I can shade in C as well. The beauty about using these colours is that the union is going to be just anything which is shaded, and the intersection is going to be anything which is shaded green where the two overlap. So because we're looking at the union of these two sets, we're just looking at anything which is shaded at all. So 5 plus 6 plus 10 plus 3 plus 4. And that's going to give me 7, 17, 28. So 28 is the answer for that one. Okay, so here we go. Similar type question. And we're looking at the number of elements in the union of A and B. So the union is anything which is in A or B. So 6 is in A, which is good. 3 is in both, so that's fine. 8 is in B, which is fine. And 2 is in B as well. So overall 19. Okay, the next one is A intersection C. So where A and C intersect, and they don't. You can see those two sets don't intersect. They don't overlap. So there is no intersection. So the answer is 0 for that one. Or you could say empty set. But no, just 0 because it's the number of elements as opposed to the elements themselves. Okay, B intersection not C. Okay, so B, we can shade in one colour, and not C, we can shade in another colour, like so. And the intersection is anything which is shaded in green, because this is where they overlap. This is where the set B and not C overlap. And that is 3 and 8. So the answer to that is 3 plus 8, which is obviously 11. Okay, next one. So we've got not A, union not B, union not C. Okay, trickier, this one. So if I were to shade in all of not A, not B, and not C, this is what it will look like. That's not A. I've added not B in blue, which has made the intersection of those two sets green. And now I've shaded in not C in pink. And what you'll notice is that every area has been shaded by at least one colour. So because we're looking at the union, we just need elements which are in one of those sets. And all of them are in at least one of those sets, which means all of them are in this set, which is not A, union, not B, union, not C. So we need to add up all these numbers, basically. So we've got 6 plus 3 plus 8 plus 4 plus 2 plus 5. So 6 plus 4 plus 3 plus 8 plus 2 plus 5. And this is going to give us 21 plus 7 is 28. And just to hammer this home, because I know that some people find the union more confusing than the intersection, because the intersection is nice and clear, it's just like where the two sets combine. The union, again, you just need to be in one of any of them in order to be in the union. The union's very inclusive. So if you look at this diagram again, then every element is in at least one of those sets. So that one is in not A and not B and not C. This one's not in B. This one's not in C. That one's not in A. That one's not in A. That one's not in A. So they're all in at least one of the sets, and that means they are all allowed in the union. Bye for now.